Okay, let's look at several examples of solving right triangles. So what exactly does that mean? Well, a right triangle means it has a right angle, right? A 90-degree angle. But to solve it means you're finding all the missing angle measurements and all the missing side lengths. So recall that typically we use capital A, B, and C for the three angles, and the sides that are opposite of those angles are denoted with lowercase a, b, c. So therefore, we have angle C in all of these, which we always refer to the right angle 90 degrees as C. So that one's kind of a given. Angle B here we don't know, so therefore this is angle A. All right. So the measurement of angle A, I included that notation right here, this little M angle. If I wrote the measurement of angle A equals 30, which is given, right? That's one way of writing it. Or this textbook in particular likes to do this. So this little angle sign with a arc through it means it's a measurement. That works too. Sometimes, like, it's weird to say angle A equals 30 degrees, but sometimes it's easy to see, we're talking about a measurement as well. So anyways, we have A. I've even seen this, just A equals 30, because it says solve a right triangle. So I know, capital A means the angle. So again, C is always 60, so these two are really already given to us. So the one that's missing, C is 90. Sorry about that. I don't know why I wrote 60. I was jumping ahead, I guess. B is 60 because the three angles add up to 180. Right, so now we have solved for the three angles, but now we need the three sides. So little a is here because it's across from the angle A. So little a we already have is 7, but we need little b and little c. Right, so these are, when it says solve this right triangle, these are the three things that we're missing. All right. With this one, you can use the ratios of a 30, 60, 90 triangle. Okay, but I want to incorporate trig in here. It's more common to use just set it up with trig, because if you look at this third example here, we have 62. That is not that's not a special angle of the unit circle or a special triangle. So from A, now we could also look from B, but we'll just use A because that's what's given. If I want to solve for B, from A I have this side, which is the opposite side, and this would be the adjacent side. So the formula, the trig function using opposite and adjacent, remember SOHCAHTOA, would be tangent. So I could set up an equation, tangent 30 equals 7 over the adjacent, which is b in this case, right, lowercase b. I don't know it. And then we solve, so b equals, so I'm going to cross multiply, right, times by b, and then I divide the tan 30. Anyways, 7 divided by tangent 30. And this is something you should be able to do without a calculator if we want an exact value. Some of these with a calculator, like if it's not on the unit circle or not a special triangle, you just have to do it that way as well. All right. So 7 divided by tangent 30. So for the 30, I'm going to draw this really quick again as a reminder. Sine theta, cosine theta. And then you start with your angles 0, 30, 45, 60, 90. Okay, sine is you start here, you do square root of 0 over 2, which is 0, and then 1/2, and then square root of 2 over 2, square root of 3 over 2, and then 1. Cosine goes backwards. So 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. Tangent, I didn't include here, but tangent, we have this function sine over cosine, so tangent theta, I'll just divide the two. So if I want tangent is 0, 0 divided by 1 is 0. 1/2 over root 3 over 2, I'll do this off to the side, 1/2 over root 3 over 2. The 2's could cancel, we get 1 over root 3, but then rationalize, you get root 3 over 3. Okay. So this is root 3 over 3. Might as well finish these, I guess. Square root of 2 over 2 over square root of 2 over 2 is 1. And then this last one is easy, because if we divide square root of 3 over 2 in 1/2, the 2's cancel and we get square root of 3. And then notice 1 divided by 0 is undefined. You can't do tangent of 90. Okay. So we have tan 30 square root of 3 over 3. So b equals 7 over square root of 3 over 3. But then we divide again, so it's 7 multiplied by 3 over root 3. And what I wanted to show here is, even though, on the unit circle simplified we have root 3 over 3, in this case the 1 over root 3 would have been a little quicker. It doesn't matter, because now we got to multiply by that again. Okay, so we'd get 21 root 3 over 3, which is 7 root 3. Now, using the 30, 60, 90 triangle, this one would have been much easier, right? These two sides, this side and this side, has a ratio of, you take this shorter side, the side opposite the 30, and you multiply by root 3. So this is 7 root 3. Okay. Last, to get the c, Pythagorean theorem, right? A squared plus b squared equals c squared. So to get c, we'd have 7 squared plus 7 root 3 squared equals c squared. So this is 49 plus 49 times 3, which is 147. And c squared is 196. And the square root of that is 14. Could use a calculator. Also, the reason is these ratios, right, for 30, 60, 90 is, I'm going to redraw it here, is whatever this side is, this is multiplied by root 3, and then this is doubled. So this whole problem could have been done without trig, but I wanted to start incorporating that. Okay. Likewise, I'm going to go a little quicker on this one. We have b and we have c is 90, right? So therefore I'm just missing a, which we know a is 45 degrees because, again, they add up to 180. And it's 45, 45, 90. We know the opposite sides of a 45, 45, 90 are the same. So once we get one of these, we can do the other. Okay, using the shortcut, 45, 45, 90 says whatever the side length is here, to get to the hypotenuse, you multiply by root 2. So therefore, to get back, you divide. So therefore, these should both be 7, and I'm done. Little a and little b are both 7. Big A is 45 degrees. Now let's set this up using trig, though. Okay. I guess since we're given b, let's do b. I want this side here, little a. So therefore, that is the adjacent, right? From this side, this is the adjacent. And then I have the hypotenuse. Adjacent hypotenuse is cosine, so cosine of 45 degrees equals adjacent, which I don't know it, A, over hypotenuse 7 root 2. To solve for A, we need to multiply by this 7 root 2 on both sides. So A equals cosine 45, which we know is square root 2 over 2, times 7 root 2. And 7 root 2 times 2 is, root 2 times root 2 is 2. But then we divide by 2, so we just get 7. Okay, even if you multiplied it out, you'd have 14 over 2 is 7. If you had done sine, because sine of 45 is equal to cosine of 45, right? They're the same. This problem would have came out the same. So if you used opposite over here instead, we still would have got 7. All right. This third example, we cannot rely on special triangles. We have to use trig. Again, the angle is quite easy. They add up to 180, right? So angle A, measure of angle A, is 28 degrees. Okay, they add up to 180. Now I'm going to go ahead and use this one since it's provided. So going from this angle, if we want to solve for A first, let's say, I have opposite and adjacent, that is tangent. So therefore tangent of 62 degrees equals opposite over adjacent. And to solve for A, since it's in the denominator here, we could do like cross multiplying. A equals 10 divided by tangent of 62, and you have to use a calculator in that one. You cannot do tangent of 62. So 10 divided by tangent, I'm doing this in a separate calculator. Make sure you're in degree mode. Equals, we get about 5.317, so we'll just say about 5.3 is fine. Right? Now you have two choices. We have two sides. We could do Pythagorean theorem. A squared plus b squared equals c squared. Right, since I have a and b here. Or use trig again. Again, going from this angle A, if I want hypotenuse and use an opposite, that would be sine. So let's go ahead and do it that way. Sine 62 equals opposite over hypotenuse. And solving for c, now we do 10 divide sine 62. Again, using my calculator, get about 11.325. We'll just say about 11.3 is fine. No units in this case. Always to kind of make sure it makes sense. Hypotenuse should be the largest, so we are good. So we solved this triangle because we had A, right, 28 degrees. We have lowercase a, 5.3. And we have lowercase c, 11.3. All right. The next example, we don't even have a triangle. All they give us is this measurement angle B and little a. So I'm going to draw a very generic one. Because I know B is 65, I'll make it somewhat close, I guess. We'll just say B is about there. So this is 65, this is little b, this is big C, this is little c, and therefore this is big A, little a, which is given 16.5. Alright? So what are we missing? We don't know angle A, we don't know, I mean technically, you know, big C, it's always 90, but angle A is 25 degrees, but we still need little b and little c to solve this triangle. One of them you could use trig, the other you can use Pythagorean theorem. Okay, up to you. Personally, like, once I get going in trig, I just stick with trig. So we have, from angle B, we have this adjacent down here. And then if I want the opposite, then again that involves tangent. Tangent of 65 degrees equals opposite over adjacent. Solving for little b, we would take 16.5 multiplied by tangent 65 in the calculator, and that will give us the side length b. Multiplied tangent of 65. So you get about 35.4. Okay, again, if you want to use Pythag, either way you're going to need a calculator. So right now you could do 16.5 squared plus 35.4 squared equals c squared and solve it that way. I'm going to stick with trig. We now have adjacent and hypotenuse. That's cosine. Cosine of 65 equals adjacent over hypotenuse. So to solve that, we need to take 16.5 divided by cosine 65. I should have did these calculations beforehand, but that's okay. So we get about 39.04, so roughly 39 for C, and for B we got roughly 35.4. Again, make sure that makes sense. Well, C is the hypotenuse, it's the longest, we're good. B should be larger than A, and why is that? Because the larger the angle, right, makes the opposite side larger. The smaller the angle makes the opposite side smaller. So everything checks out. That looks good. Two more examples. I apologize for the length of this video. Probably should have cut it in half. Oh well, moving on. First off, I want to point out very common mistake. Many students look at this and like, oh, it's a right angle, and then they try to do trig stuff from there. Okay, maybe it's not even possible in this one, but don't assume something that looks like a right angle is a right angle unless it's drawn with that little box like it has here. Because looking at this one, we actually have two right triangles, right? One on the left, one on the right. And if you calculated these angles up here, this one would be 51 degrees and this one would be 27 degrees, which is 88 degrees. This is not a right angle up here, right? So we don't have three right triangles, we only have two. So the idea of it is to treat them separate. I'm going to use what was given. I'm going to use this 39 degree and I'm going to use this 63 degree. I know to get x, the total length here, if I knew this length, I could just add it to this length. Okay. So we'll do pink first to get this length. I'm looking at this 63. I know the opposite side here is 82, but I need adjacent. So therefore I'm going to use tangent equals opposite over adjacent, which I don't know. We'll just call it like A, or maybe A sub 1 or whatever, I don't know. We'll just call this piece here A. So I'm going to solve that. Take 82, divide tangent of 63 degrees. You get about, I'm going to round in the nearest whole number. I'm going to be a little lazy here. 41.78. We'll just say it's about 42. Okay. Now in blue, we'll just call this one B. Again, it's tangent because I have opposite and adjacent. So tangent of 39 degrees equals opposite over adjacent. Solve for b, do the cross product. 82 over tan 39. And we get about 101.26, so we'll just say about 101. Again, depending how they want you to round it, I didn't specify here, so I'm being a little lazy. Now, x is that entire length, right? A and b. So for x, we'll simply just add those two together. X equals, I'm going to say approximate because I did round. 42 and 101 is 143 whatever units. It's what's funny with trig, a lot of these don't even have units. Alrighty. Last one. We want only this x here. Well, looking at that triangle, it definitely is not a right angle right here, right? Because this is 56 and these two line on line, they make 180. That'd be like 124. You cannot use sine, cosine, tangent on these triangles that are not right angles. The ratios are not the same. Okay, so solving this, we got to take a different approach. Instead, I do have two right triangles because I have this large triangle here. So I could get this entire length down here. Right, we'll just call this length A. Using, again, tangent. Tangent comes up a lot, just so you know. Tangent 35 degrees equals opposite 115 over A. Solve for A. Okay. But then we have, let's do blue, this triangle, which is also a right angle because of that. And again, I need tangent of 56 degrees equals 115 opposite over adjacent. I didn't name it. We'll just call this little length B. So B is 115 over tangent of 56. And then to solve for x, right, just this length here, whatever I get from A, I'm going to subtract B. I'll do the difference of A and B, and that will give me x. So let's plug these both in the calculator. 115 divide tan of 1, oops, I don't know why I have 135 here. That's just a tan. I think I was looking at that one. That's just tan 35. I'll clean that up. Tangent of 35. Okay, 115 divided by tan 35. If you plug that in your calculator again, I'm going to do a whole number. We'll just say about 164. Okay, now we'll do B 115 divided by tan 56. Get about 77.56. We'll just say 78. So that length x then is about 164 minus 78, which is what, 186. Yeah, 86. Alrighty. And again, that makes sense, right? If this is 78, it's 86. We got A as the whole length.